all I want you to do is just tell your friends about this, because trust me, today's session you're going to gain lots of insights, okay? And it's going to be like twofold. It will still be part of your data mining workshop, which didn't happen. All right. So in case if they are unable to, yeah, thank you. In case if they are unable to watch the live stream, still tell them, yeah, Purushottam, welcome back. Yes, John, yeah. So I just want my, some of my students to get to know you as well, John. So, guys, so we have somebody from 5th grader. So I believe he should also be able to understand. All right. Okay, cool. Okay, so yes, thank you so much. Keep joining. So what I want to tell us before we start is this, that this will also form basics of your deep learning class, because in the subsequent sections, what I will do is kind of, apply deep learning, okay, to this, whatever we are going to build today, okay? And in most cases, we try to like deploy this and kind of make prediction in real time, okay? So for now, there'll be lots and lots of read-ups. So like some of you suggested, Sassy, we are bored of you explaining the basic stuff. Can we just work on projects, okay? Actually, it was just one person. So I thought he just echoed the minds of others. So on that note, I thought, okay, fine. Let's just, work on one project, and so that you guys will understand what is really happening, okay? And how you can actually combine all that, We have not learned so much, guys. We have not learned so much. But since this live stream happens once every Sunday, and since I captioned it project-based machine learning, right? So I'll be skipping, most of the fundamentals. However, if you have any doubt on anything, guys, please feel free to get back. And I want to thank most of the viewers, guys. I really didn't believe that, in a short while, I can get a video, one of my videos will cross 2,000 views. So I really appreciate you guys, man. It's because of people like you that I keep doing what I'm doing, right? So yeah, having said that, I want to tell you something else about my new channel. So what happened, as you can see on the screen, this channel, I can see this video, okay, but I think YouTube deleted it because they said it violated, I think, their privacy stuff or something like that. So maybe why that happened was because, yes, I copied Mr. Bean, and I actually tagged him here also, and I tagged YouTube. So yeah, because of that, obviously, I will not be tagging anybody. I will not be cropping stuff, okay, from people's stuff and then be putting it here. I will just do it my own way. So guys, if you are still subscribed, don't think, okay, my channel is this new channel is no longer available, you have to unsubscribe. Please don't do that. More of videos, interesting and fun videos is coming up in the nearest future, okay? Even tomorrow and day after, I'll be uploading some stuff. All right, so that is by the way. So what are we doing today, guys? If you look clearly, we are going to look into what? Heart disease prediction using what? Machine learning, right? So permit me to scribble something in case you are unable to, follow. So I think my writing is not that good. Not that I think, obviously we know my writing is so bad. So I'm going to type it. So what are we looking at? We are working on what? Heart disease. Fine. Prediction using what? Machine learning. Now, but what did I say here? I used another keyword, right? So in between, I was trying to tell you something about Ensemble. Okay? But we will come to all these things later. Fine? So for now, let's understand why we have to work on this project. Okay? So I want to say this up front. I'm not a cardiologist, right? So whatever we are going to do, we are going to look at historical data. Okay, so what I mean by historical data, okay, audio up, okay, sure. Amanat, can you just tell me, am I not audible enough? Amma, can you confirm, please? Purushottam, please, can you confirm? Because John says audio, I should increase it a little bit. Okay, So what we are going to look into now is how we kind of predict, heart disease, okay, using machine learning. All right. Now, another thing you should understand upfront is this keyword called Ensemble. We'll look into that later. But before that, let's understand why we have to predict heart disease. Okay? And why is this such an interesting, thank you, Diksha. Why is this such an interesting project to tackle? All right? Now, I'm going to show you something here, and then we look at it from other, point of view. It's always better when you are talking of something, you should talk from experience, right? So, yes, I have personal experience, and you also know, I'm pretty sure almost every one of you know someone who has suffered or who has been a victim of cardiovascular disease or heart disease or any of them. Fine. So we take some dictionary meaning. We look at dictionary meaning of heart disease, including the generic family of cardiovascular diseases, right? So before that, guys, I want to tell you something, and it's better if I just show something here. All right. So can any of you take a guess what this is? Can any of you take a guess what that is? All right, John, you are free to go and join back, no problem. So can any of you take a guess of what this is? By the way, this is me, right? So I don't want YouTube to say I violated the terms and conditions or something like that. So please, anybody, yes, I know many of you are preparing for your internals. No worries. But if you are here, can you just let me know what you think this is? What is it actually? All right, any guesses? Diksha, can you just type something? Amanat, can you just type something? Purushottam, can you just say something? All right. So looking at what I projected on the screen, what do you think it is? All right. Okay. So I know for most of you that will be joining us later, right? So this is my long ultrasonography. Can you call it long ultrasonography or chest ultrasonography? Okay, so it's a CT scan of my heart muscles, all right? So, but actually, why did I just do this? So, I woke up one day, I had this kind of chest pain, okay? And by the way, it just costed me 2,600 rupees. So 2,600 rupees will be around maybe 15,000 naira. And then maybe that'll be around, it's not up to $100, guys. Yeah, maybe around 40 USD, okay? So maybe I might be exaggerating, yeah, around 40 USD. So I just woke up one day and I felt, that burning sensation. And in between, I felt like, it felt like my heart muscles were collapsing. So I thought of something, I don't want to take a risk, right? So this might be an onset of CVD. Why am I telling you all this? Whatever we are going to build should not substitute human expert opinion. Remember, machine learning is still at the what? Elementary stages. Maybe I can call it UKG stages actually. Many of the stuff we build, most of the models we build are still not ready to be deployed in real time. Okay? That's why you see machine learning should not be taken, implicitly. Like you still need validation from expert opinion, or you still need expert opinion, which you call your ground truth, or your ground truth basically, or a clinical validation. So back to what happened, right? So I got that sensation, so I thought of something. Since I stay alone, I really need to get this diagnosed once for all. All right, Diksha. So I said it's a CT scan, image of mine only, okay? Now, what I decided to do was I just asked people, okay, I need the best diagnostic center in Mysore, and I was referred to Canon. Now, I'm not paid to promote them, obviously, because they even refused to give me my data set. They just printed it and gave here. And this was when, as you can see it clearly, this was 3 months back, right? Fine. Now, when I reached there, what they did was try to kind of, I think before I look at this ECG, oh, sorry, I said CT scan, please. Actually, it's ECG, right? Yeah, I think it comes under CT scan. Who knows? But anyway, fine. So echocardiography, right? Now, before this, what he did was trying to put me on a treadmill test. So I think I should start from there. So you look at this, fine? So it's called TMT. And what I want to tell you is this, because you will understand all this as we begin to work on the projects together. There's something we call clinical history. You know, when someone suffers from things like this, the doctor will ask you salient questions, and please don't lie to them. Because immediately I walked in, he asked me which country. I said Nigeria. They started speaking Canada. So they said all kinds of stuff. I just kept calm. Then he asked me, how many packets of cigarettes do you smoke per day? I said, I have not even tested one. He looked at me like this. He's an old man. He said, okay, we will see. He asked me, how many bottles of liquor do you take? I said, I have not taken one. I'm a complete teetotaler. Got it. He said, okay, do you have any family history? Anybody in your family who has, suffered from this or who has succumbed to this disease? I just bent my head down. I said, fine, yes, I do have. And he said, okay, based on, the observation, I'm likely to have maybe a blocked artery. Got it, guys? So now we started the treadmill test. Fine. So when we started the treadmill test, I want to show you before we go to the summary. Okay, this is the summary of the test. But before this summary, let's go to the graph. So you see, I have ST level, ST slope, and all whatnot. And please look here. Let's on basic things at least you can understand. At 0th minute, 0th second, that means at the resting stage, my heart rate was 71 beats per minute. All right. Now, the grade was purely flat, 0. And my BP was perfectly normal, 120 on 80. No abnormalities so far. All right. Now, he started the test. Fine. After 41 seconds. Okay, by the way, for the TMT, I don't want to tell you about all this. They're going to attach so many things, okay? They attach here, there. I don't know what they call it. I don't want to talk about that now. So, yeah, at 41 seconds, that means as soon as we start, the reading was taken. Okay, even in between also, I think 10 seconds at grade 0 and 0 speed. I think we're just starting. Now, the speed was increased to 2.5 kilometers per hour, and the incline was around 10%. Now, my heart rate has come up to 128 beats per minute, and my BP is around 150 on 80. Remember, the normal one is like 120 on 80. This is stage 1, okay? So look at the graphs and all whatnot, and then we move to the stage 2. Now, the speed is little faster. Fine. Inclination also is there. Now, my heart rate is still constant. The BP is still constant. Heart rate is at 137 beats per minute. Okay. Let's look at the speed of, this is stage 3, 5.4 kilometers with an inclination of 14%. BP has come to 160 on 80. Heart rate has jumped to 151. All right. Let's go to stage 4. So this is the stage, I think the extreme stage. I don't know why he called it stage EX. The speed is now 6.7 kilometers per hour. And the grade is around 16%, and my heart rate is around 175, and the BP is 170 on 80. So I think, yeah, after that, then I think this was the peak, right? The peak exertion. I think this is peak exertion, okay? So I tried to, ask a couple of questions, but in between they felt uneasy. Then I left them, fine. All right? So if you see, this is the recovery stage, because I'm an athlete. Okay, I try to run. I won't say I'm an athlete, but yeah, I try to do little things to keep myself healthy and stuff. So after the whole thing, recovery stage, and there you go, and there you go. I think lastly, recovery stage 3, the heart rate is dropping, 110. Here it was 147, 150 on 80, 110, 150 on 80. I think the last one, 106, 150 on 80 at 0, blah, 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 okay? And finally, this was the data he captured. Okay, Now, this is a summary of the entire thing, right? So, the total execution time was around 12 minutes, right? So, maximum BP was this much. I think this threshold value, some stuff like that and things like that. I think 95% of whatever exertion was there, and this is a summary of or whatnot. Now we are going to look at graphs like this in the near future. This is your what? If you look at it properly, you see it is what? What type of graph is this? Okay. Remember, I'm not talking about this plot. This is a histogram, right? But this looks like my Gaussian curve, right? So everything is like evenly distributed across along the mean, right? Somewhere here, okay? So look at this is the heart rate at particular stage. This is the BP at particular stage and stuff. So this is, can I say this is left skewed or right skewed, or is it distributed around the mean? Almost. Now let's go, what interests me was the summary. Now what he did at the end of it all was he took this, okay, and they printed something like this, and he was really baffled. He was like, let's go back here. He was like, wow, you are in a perfect shape. Why did you come for the test? You know, so this is the treadmill test. No hypertension, no diabetes, no this, no that, no obesity, nothing. Supine within normal limits, standing within normal limits, hyperventilation within normal limits. So yes, Fatima, bar graph, yes, but since the bars are cluttered together, so it's called a histogram. So yes, I agree with you that it's still a bar graph. Fine. So you see indications for the treadmill test. They want to check evaluation of my BP response, evaluation of atypical chest pain, because that was what I complained of, right? Screening of coronary artery disease. Fine. All right. So why did I tell you all this? Should you have anybody who complained of heart, pain or anything, please let it get checked once, okay? At least let them just consult a cardiologist. Fine. Now let's get back to this. So what he did here was, I think this is the morphological data. The valves are normal. Everything is normal. Aorta is normal. Pulmonary artery is normal. Regional wall abnormalities, everything. I mean, there's no regional wall abnormalities here. Pediocardium, whatever, is normal. Pediocardial effusion is normal. Now, there is no regurgitation here. Fine. And everything seems perfect. But still, I wasn't convinced, right? So he now reported that, look here, that based on these people, okay, sorry. He now said, okay, fine, let me just, take you back to the, let's do an ECG, right? Or whatever, echocardiogram, whatever. Now, I could literally hear the sound, in between it to do choco, 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 choco. Okay, fine, don't mind me. Some sound, will, come. And then after some time, this is the report also. So I think this was the report of the ECG, right? So again, echocardiogram. No, it's a normal study, no regional wall motion, normal valves, everything is intact, normal, whatever. I think this is left valve, I think so. So why I'm actually putting this out here is, in case if a medical doctor or maybe a clinician or somebody happen to bump into my YouTube channel, I would really love if you can throw more insights on this, okay? Fine. Now, no PAH, no clots, no pediocardial effusion, nothing. Okay, everything was perfect. I say, yeah, thank God. Fine. Now, I also did another test, okay? That is to understand how my internal organs are functioning. That was done on 15th of May. And again, everything is normal. In the subsequent class, as we begin to work on most of the medical data sets, I will put that out also. So why did I tell you all this now? In today's session, we are going to look at what? Cardiovascular diseases. So let's ask Google what this is actually. In case, yes, you are joining us for the first time, right? So I'm going to take help from Google, right? And I'm going to ask Google what is a heart disease. Fine? So just ask this thing. What is heart disease? Before we predict it using machine learning, what is this heart disease? Fine? So if you Google this now, you're going to get that heart disease. Let me go to Mayo Clinic. I most times refer to them. Or I go to Center for Disease Control. I think this is more trustworthy. Why? This is from the US and it is just updated 5 days ago. Fine. All right. Can I just chip in one more thing here? Why I'm actually taking time to explain this is, I have seen a couple of research scholars, would-be PhD graduates, They don't even know why they're actually working on a research problem. Yes, I'm not saying I'm the Bahubali of research, but at least I'm not wasting your time either, all right? So I want you to understand the background of this study and why this is actually important. Because almost every one of us, in one way or the other, would definitely have to undergo a heart test one day, fine? And it's not that expensive in India as far as I know. So let's go back here. I think in government hospitals, you might get it around $700, right? Correct me if I'm wrong. So let me start from CDC. So what is this heart disease? So the term refers to several. Got it now? So not only like, massive heart attack, it can also be a coronary artery, whatever, like things like that. Any blockage or anything that obstructs. So it can be anything, even angina, I don't know how they pronounce it. Anyway. So the most common type of heart disease in the United States is called what? Coronary artery disease, CAD. Because you see, most times when I work on projects, I'll be using the term CAD, and that's why appendices are required. CAD can also mean computer-aided diagnostic tool, okay? So, or computer-aided diagnosis. That's why I prefer to use CDSS instead of what? CAD. So I'll use CAD to refer to coronary artery disease, and I'll be using CDSS to refer to a model which we call computer decision support system or clinical decision support system. Fine? So here, the main one is what? Coronary artery disease, which affects the blood flow to the heart. So decreased blood flow can cause what? Heart attack. So what are the symptoms? It starts with chest pain or discomfort in the upper chest. So even me also, like, you get indigestion. At times I used to get that. Okay, then neck pain, but that is as a result of indigestion. Okay, but yeah, and heartburn, nauseated, you feel like vomiting, extreme fatigue, arrhythmia. You feel that that palpitations in the chest, and shortness of breath. This is usually the chronic one, right? And then you have fatigue or swelling in the feet, ankles, legs, abdomen, necks, and vein. So what are the risk factors? So those that smoke, fine. They better quit smoking. So you see, the major risk factor here is high blood sugar, high blood cholesterol, high blood pressure, I beg your pardon, high blood cholesterol, smoking. So you see here are the major risk factors. Yes, how about those? I know some people that they smoke like crazy, still they don't have any of these diseases. There might be an exceptional cases, right? So about half of the people in the US, how about India? About half of the people in the US have at least one kind of these, risk factors, one of these three risk factors. Okay? Now, what is this cardiac rehabilitation, right? Because you can actually reverse it. Yes, is heart disease reversible? I'm not sure, but you can actually reduce the risk of having any of the CVD. So you exercise like I do, all right? Dab for me, all right? So you exercise, and obviously don't forget to consult your doctor or your clinician, because I train a lot. Still, I look at it from the clinical point of view. Don't go beyond your limit. Fine. So you've got an idea. And if you get back to Mayo Clinic, they describe some of them. All right. So blood vessels, coronary artery disease, arrhythmia, what is called congenital heart disease. I'm a computer guy, right? I'm trying to form medical students. All right. So, and you have seen that whatever, so there is a correlation between what CDC is reporting and what Mayo Clinic is reporting also. So having said all this now, the next question is, can we actually predict the onset of heart disease? Before predicting it, let's understand how you diagnose heart disease. I have shown you, right, from my own medical record. That is how heart disease is diagnosed, right? You have to get to a medical doctor. You have to present your case to him. He has to first start with a clinical thing. So maybe let's see if they did it differently, right? So you now say, how do you, heart disease. I think I called it diagnosis. Fine. Diagnosis. All right. Okay. DIA, diagnosis. Fine. Or diagnostic tests. So you have seen that, right? So electrocardiogram, that is ECG, which I just showed you. Exercise stress test, that is your TMT, right? Treadmill test. So these both I did. Now X-rays and, oh, sorry, I think I did this. Yeah, same. Echocardiogram, they can actually do blood tests. Coronary angiography, this and MRI scans. All right. Now, can we use can we apply machine learning technique here? That leads us to the next question. What is machine learning? Now listen guys, I'm not going to, dwell more on the fundamentals again, all right? So we will get back to this most of the times and study many of the things in depth. Simply put, let's answer this with an image because they said a picture is worth 1,000 words. What is this guy? In case if you're a complete novice and you want to understand, are we referring to a moving object, right? Okay, so what exactly is this? Now, if I look at this, dictionary meaning is the use of, think of it computer, okay, that is able to learn and adapt without following instructions. Don't get confused. By using some magic thing, which we call algorithm, to analyze data and draw inference here is known as conclusion. Okay, let's look at one image to have a clear picture of this. All right, so look at this human, look at this machine, okay? So human says, I can learn everything automatically from experience. Can you? The machine says, yes, I can also learn from past experience with the help of machine learning. What did you understand here? He has lots of knowledge base. You can see the books here, right? So these books refers to his knowledge base, and which we, invariably call what? Data sets. So without data, there is no learning. All right? So because of that, we need what? Access to data. And I want to tell you something else. If you look at my result of some medical reports, this report is in which format? It is in an image form, right? Fine. We have people we call medical transcriptionists. I think that is the term. Okay. Medical students, don't chew me, right? I'm trying to form a medical doctor. All right. So there are, I think, medical coders, I think. So let's ask Google instead of just thinking, and they say, who is this guy? He keeps thinking. So I think medical coders. Fine. So is the transformation of healthcare? Yes. Into universal medical alphanumeric codes. Okay. All right. So I think, yeah, medical billing, I think maybe anything, but you got the idea. Transcriptionists. Yeah. So I think it is their duty, yes, known as this professional recorded medical records that are dictated by this. Okay, sorry. This is about dictation, okay? They'll be writing it down. But I think it's medical coding, okay? So they will take this clinical data now. Please listen. They will take this data and then convert it into a form which is easily accessible. Now, one of the forms what I mean by form is like a format, right? Let me call it format now before you think it's another Google form. So this format is the format that is usually, universally acceptable. Example, we have this which we call what? Diacom Formats, which stands for Digital Communication of Medicine. So let's look at this Diacom format, DICOM format. Okay, okay. So let me go to that. And at times, they will export this, consists of a header and an image data set packed into a single file, right? So this information, okay, the information within the header is organized as a constant and standardized series by tags. By extracting data from this, one can access important information. So in computer science, we call this data your metadata, M-E-T-A-D-A-T-E. So what is this DICOM, right? So it stands for Digital Communication in Medicine, right? So you can already see a kind of a CT scan image there and things like that. Fine. And this DICOM format is Hipaa Compliance, H-I-P-A-A. Is it Hipaa Compliance or Hipaa Compliance? Okay. So it's I'm a Nigerian guy, so you should understand my accent. It's called Hipaa Compliance or Hipaa Compliance. What does it mean? This is kind of, a kind of, what do you say, a policy that is set up, again, by the CDC, I think in the US again. So this stands for what? Health Insurance Portability and Accountability Act. I think it was set up in 1996, okay? Now, so it's kind of try to protect the patients. Now, when you're working on projects, you refer to them as customers, but here we are going to refer to them as patients. So this patient information should be de-identified. If I have access to someone's medical record, I should only use it either for research or to help the patient, and not just, to identify and kind of jeopardize them, right? For example, if you know anyone who has HIV/AIDS and you are working on a research and maybe the person happens to be somebody you will look at them differently, yes or no? Similarly, if you know someone also who has corona, remember when corona came, right? In India, wow, it's like a death sentence, right? Even I learned that some people committed suicide because they were diagnosed with corona. So because of that, all these policies were set in place to protect the consumer from what? To protect the interest of the what? Not consumer, please. Yes, patients, okay? So first thing we need access is what? Data. So I want to tell you one thing here. I have actually worked on this project before. I applied Ensemble machine learning. So I will tell you what Ensemble means. Ensemble is another word for what? Aggregation. Say example, okay? I just believe, yes, you are new to machine learning, but it doesn't matter. So let's look at something here. Don't worry. Ensemble. This means combination of more than one machine learning algorithms. I hope you got that. Let me not write something. So when we start building this model, let's say we have, I'm going to call it model 1 now. Don't think about the name. Model 1 gave me an accuracy of, say, 92%. Now, model 2 was able to predict whether this person has CVD or not with an accuracy of 95%. Model 3, let me stop here, gave me an accuracy of 99%. So let me ask you this simple question. Which model is the best model here? Obviously, model 3, right? All right. However, can the accuracy be improved by combining model 1, model 2, and model 3 and taking the mean score or the aggregate? So can somebody help me do this math? What did you get, Diksha? When you add up these 3, what did you get? All right. So I'll be getting around, who knows? Okay, let's say I get like 95% approximately. All right. Now, if you watch, then this model is actually less than the aggregate. But in some cases, after you do ensembling, you notice that actually the aggregates might even go beyond the best classifier. So this is what we are going to do. And we'll be looking at around 7 machine learning models, 7 of them. All right. So in case you just breezed in, now remember, this is both your data mining project, data mining workshop, alongside your machine learning workshop also. Okay, fine. Now let's go with the first approach, looking for the data. Now, can I tell you what happens in machine learning? Can I just tell you something here? So we can say the overall process actually of machine learning is all about what? First, step 1. Can I use some pseudocode here? Step 1, you gather the data. So I'm going to call it what? Data gathering. And somebody might say data, plural, datas. It doesn't really matter. Data is plural. Singular form is datum. My dad taught me that. Okay? Datum, okay. That is singular. And the plural form is data. Nothing like datas. Okay? Plural. All right. So when you get here, the first thing is what? Data set gathering. So data set gathering. So we get these data sets. Now after that, we might look at the next step, trying to understand whether there are missing attributes or something. So for that, I'm going to give some name now. It's called exploratory data analysis. Fine. So in exploratory, we are actually looking for outliers, looking for things that kind of is a deviation from normal, right? So after this is done, then if we get that, because we'll be studying about use cases of which machine learning algorithm, right? So with that, we now translate to step 3, where we look into model building, step 3. So what we do, please listen, this is not an extensive step, okay? It's just kind of, I'm giving you a kind of an overall process, or you call it a overall sequence diagram. Fine. Now, next we have to now build the model. Build the model. Now, that means for us to build the model, we have to do feature selection, feature extraction, and or whatnot. And then, extraction followed by selection or whatever. That means, in this cell, no, you skipped pre-processing. Exactly. Pre-processing also, I can class it under what? Exploratory data analysis. So the main thing here, we do pre-processing. At times you do data augmentation, at times you do or whatnot, okay? So I can call it data augmentation here, no problem. After this is done, all right, now we need to now check the accuracy of the model, right? So that means as we are building this model, we'll be using something like, train, test, and split, train, test, and whatever. We split them, and then we just do some validation, okay? No problem. And then we now have to what now? Check how well this model has performed, right? So maybe I can stop here. After we have built the model, we now test the model, fine, and then we deploy it in real time. We test the model. Okay, so here I'll leave for training. And finally, we now, deploy the model, right? So it winds up with what? Model deployment. That means that the model is ready to work in real time. Fine. Deployment. Okay. Sir, can you stop writing? Your handwriting is so bad. I'm really sorry about that. Okay, so what is the first step? Let's go get the data. And back to my Jupyter notebook, all right? I actually did this before, but let me tell you one thing here. Let's just quickly go down, and then we're going to build all these things as you look at me here, okay? So you see, after this ensemble technique, what did I write as conclusion? Please look here properly. I said here that extreme gradient boost gives the best accuracy, followed by KNN and SVM compared to other models. Now, the least accuracy was from decision tree. Please listen, guys. Please listen. What are you talking about? Look at this table. Just help me look at this table once. Okay, I zoomed it in so much. So I use logistic regression, naive Bayes, random forest, extreme gradient boosting, K nearest neighbor. Fine. Decision tree and what? SVM, right? Okay. Did you notice here SVM was giving us, sorry, where is extreme gradient boosting? Sorry, 91. Oh, sorry. I reported it wrongly. It was SVM actually. SVM was 98, okay, followed by this guy, 91. All right. But we are going to verify something now, all right? So where is the data? How do we start? So in today's class, I'm going to leave Google Colab because the problem here is after I finish training the model and I give it to most of you, actually I gave it to a couple of people, it was difficult for them to kind of replicate this project. And if you are watching, okay, I'm not trying to put you down or something. I'm just trying to, learn also, put myself in your shoes, okay? So because of that, I will tell you what to do, fine, in this case. So if you watch closely, let's go back to the data set, the data source. So you see this, right? Content/drive/my_colab/notebook/something, right? That means, go up, did you see this? I have to mount the Google Colab. But in today's session, I will leave Google Colab for now, and I will get back and do it offline. Agreed? So first thing, I created a folder, as you can see on the desktop. I call this folder Heart Disease Prediction. Let's go get the data set. Fine. Now just type, very simple. Actually, I made a video on why not Kaggle. I think it should come up. Why not Kaggle? Please feel free to look into this, okay? So I think it should show why not Kaggle. If I go to video, I think it's been ranked so less. Okay, so the essence of the video was just to tell you that virtually every data set is available on Kaggle. And in case you are joining us for the first time, you should see that Kaggle is what? A repository. And please listen. In the subsequent classes also, I'll be disputing what I'm going to say now, okay? For now, remember that Kaggle is a repository where you get access to one of the finest, codes online and all the implementation, as well as you have access to GPU. I believe you know what a GPU is, a graphics processing unit, at no cost. And Kaggle, is like, it has a huge, number of contributors. We are going to see it right away. Fine. Mostly, it's like a kind of a Stack Overflow for data scientists. I believe you know what Stack Overflow is. If you are a coder, if you're in Nigeria, we say coder, fine. If you're a programmer, so you remember that at least Stack Overflow, okay, you must have bumped into it one day. Must. So we don't go and type Stack Overflow and start looking into it. We normally get in there when we have an error. Example, okay, there will be some error here. It says Stack Overflow. I don't want to type this. See here, panda, something like that, value error using string. Immediately you type this, you see it gets by you to Stack Overflow. Now, leave it. Am I confusing you? No. We are looking for our data. Now, what am I going to do? So I'm going to type now heart disease prediction. Okay, heart disease prediction using machine learning. That's all I typed, guys. I get on analytics video, I get on this, I get on everywhere, I get on things, I get on IEEE. But what I want is, say, Kaggle. I just append Kaggle by the side. So Kaggle will pop up. I'm going to click on this, go to new tab. Fine. And what I will get here is, please look here, guys. Just watch here. If you look at this, you see predicting heart disease using machine learning. And this person he won a gold medal in this competition, and he has 239 upvotes, meaning you can actually rely on this. And yeah, these are kind of, I think, edits. Okay. Now, if you look at all this, please listen. You're going to see everything about the data sets, right? Right? So it says here, the problem definition is in this statement, giving clinical parameters. That means, unlike my case where I presented you with the raw facts, medical coders, maybe, I don't know, coders must have done this and converted it into what? Historical data, and saved it in a form which is almost well acceptable. That form is what? CSV format or form. That is comma separated values file. So in case if you don't know, you can gulu comma separated values, which is similar to my text file. So it is a text file, like .txt file, that has specific formats which allows data to be stored in a table structured format. If that is the case, we are going to look into this. Fine. Now, this is the problem definition, right? So you are supposed to predict whether this patient has heart disease or not. That means we are going to have, again, what we call a target variable. We're going to look at it now. 1 means the disease is present, actually to be yes or no, based on the historical data. Fine? So if you want me to convert mine now into a CSV format, we can start from here, right? Normal study, yes or no? Yes. Okay? Normal region, motion, whatever abnormality, no. No region, whatever. Just take yes or no, yes or no, yes or no, yes or no. Based on all those yes or no, 1, 0, 1, 0, will I be able to have heart disease? No. I'm perfectly fine. So the same thing we have here, and we're going to click on this data. Fine? So once you click on data, what are you going to get? So he says this data is no longer available because it is a private data source. No problem. I will leave this guy alone. I will just go here. Instead of saying Kaggle, okay, I just say Dataset. Fine. All right. Now, I want to tell you one thing, that this dataset is actually originally from UCI repository, okay? So I will just say UCI, and there are so many of them. UCI Heart Disease Dataset. Fine. UCI stands for University of California, Irvine. As you see, I have actually visited this. Contributed in the year, I think, made public in the year 1988. Most of you are not born then. This is the official data repository, and it consists of some attributes, 75 of them. Okay, categorical, integer, and stuff. It is mostly for classification. There are no missing number attributes here, and this number of hits it has generated. And these are all the information you're going to get again, 14 of them. And the last is what? The predicted stuff, which is a number, right? The predicted variable, which is either yes or no. So you see age, sex, CP, threat, whatever, you can actually see it here. The ID is removed. So these are like the 75 attributes, which they have meticulously removed unnecessary attributes and only presented us with the clean data. Please listen. There are 75 attributes that was collected by the medical doctors. And look at them here. Look at them, the medical doctors. See creators, Hungarian Institute of Cardiologists, Budapest. So I think Andras Janosi, medical doctor, William Steinborn, this and that and that and that. Fine. Now, after, we are not going to use these 75, right? However, we have to look for a specific data set. So if I go to the data folder, now listen, again, I will dispute this. I wouldn't want you to come here. You're going to see so many of them. This is from Switzerland. This is from Switzerland process. Can you see that? You see pre-processed Switzerland process. These are blah, 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 blah. And you see this, which is the Cleveland data set. Fine? So my work will center around the Cleveland data set. So on the Cleveland data set, I'm going to take some of this stuff and I will make predictions, right? Okay. So instead of us to come here and download the wrong one, because whatever we download, we need to take the metadata alongside. Okay. So what I will do is, I will go back to my Kaggle, right? And I will take it from there. Okay, guys? I hope I have not confused you. So if I get back here, I'm going to get heart disease data set. Okay? So that's what I just typed, okay, on Kaggle. Fine, I'm closing all these unnecessary ones for now. All right. So this is closed, that is closed, and that. Fine. Now, with this, you see download. Okay, I was on data. Okay, you can actually see data. You can see how many codes, 97 people have actually worked on this, and discussions and things like that. So I will just go to data. You can actually see it here. You might feel free to look like later down actually and see similar data sets also. Novel coronavirus data set, chest x-ray on pneumonia. This is PIMA Indian diabetes. We'll be working on this also, diabetes prediction, and heart attack analysis and prediction. This will be an extended one. See, most of them are in CSV. And all I need to do is, you see this, some stuff, we are going to replicate things like this. I'll click on download. Fine. Now, when I download this, please listen, it's going to go to my download folder, and I'm going to get this as archive. Okay. So all I need to do is extract this. Done. I think that is done. And you see it's called heart.csv, right? So what I will do is I'll copy this out, Control C, Window D, and I want this folder. Find this project folder, Control V. Fine. So this is the folder where I'll be working from. Why? I will tell you. I want, you see this IPYMB extension. Did you see that? I want this IPYMB with the data set to be in the same directory so that I don't need to give the absolute path. So let's explore this from our visually, right? So before we start writing code, let's see if we can actually understand what is happening here. All right. So look at this carefully. I'm not going to repeat what these columns are again because we have actually seen them. So what I will do is I'm going to look at this and say, okay, find age, sex, or whatnot is there and things like that. Okay. So I think my system is beginning to hang. So I will go offline. Pardon me for that. I mean, not offline. I will turn off my webcam and let's see. Okay. All right. It's called a video capture. I turn it off and there you go. All right. So let's get back. Okay. So this is actually hanging, but you got the point, right? So these are all the stuff. But please look at this carefully, guys. Look at this carefully. You see the last column is called targets, right? So let's count this now. We don't no longer have 75 columns or attributes. Okay. We now have around 14 of them. Let's count. 1, 2, 3, 4, 5, 6. Okay, it's done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And did you see the last one is like a target, which is either 0 or 1, right? Yes or no. So based on all these conditions, right, this person is likely to have a heart failure or heart disease. Fine. But did you notice something else, guys? The values are kind of not a representation of, not evenly represented. I'm not saying the data set is not evenly represented. I'm saying the values. How do I mean? Or what do I mean by that? Look at age, right? Now, let's look at all this stuff first. Are there numeric data? Yes. All of them are numeric data, right? There is no categorical, apart from the heading is categorical. So we can actually remove this, or we will use code to remove the categorical data and then have numeric data. Remember, machine learning works best only on numeric data sets. Fine? So if you look at this carefully, you see age 52 something, then you see sex, which can either be male or female. Yes, there is not gender, but I'm not sure why it was not captured here. Okay. Now, you have this 1 and 0. Fine. That means this is male, 0 is female. And look at this value, TSB, TBSP. It is 140 something and things. Look at cholesterol, very high. So if you want to build a model, just watch. Comparing sex with cholesterol, okay, gender with cholesterol, what do you think? Obviously, the model will be biased, right? So we're going to handle all these things, okay, which we call like scaling, okay, or standardization. We need to like normalize all these values. So you see this also, same. So there are values that are like outrageous. I mean, so big numbers, okay? So they are very big. That is this talak, cholesterol, trace BSP. And again, you see, we are going to have again what here? Decimal number. That is real number or floating point number. So we work on all these things now, and there you go. So we have seen the data set, and we look at this actually. Do you think there are missing attributes here? I mean, missing columns? I'm not sure. So instead of us to waste time, this is where pandas comes into play. Fine. So we're going to start with this, starting with a new notebook altogether. So for that, what I will do is, you have seen all this, right? And you have seen this stuff, right? So I'm not going to run it again online. Fine, I'm going to run it offline. And there you go, and there we start, okay? So what I will do is I'm going to kind of call up my Jupyter Notebook. So what I will do, I will just type Jupyter Notebook, that's it, fine. Okay, it's actually running, but anyway, yeah, let it be. So Jupyter Notebook has opened. So what I'm going to do, I'll drag it and keep it here so that you can actually see it. So this is all we have, guys. And then in there, we need, please, if the network drops, I really want somebody to message me, okay? All right. So in there, what we have is, we go to desktop to locate where the folder is. And then we have this is called hard disease prediction. And I already have one running, but I'm going to start afresh. So I click on new. I'll say Python this, okay? Now, once that happens, it's going to open up in another browser. Fine. Now, so here we are, and we're going to call this now what? I'm going to call it cardiovascular, cardiovascular CHD, okay? Okay, instead of that cardiovascular, blah, 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 let me call it what it is, heart disease spread, okay, using something ML. Fine. Done. Okay. Now, first thing we need to do, guys, we need to load the data set, right? So for us to load the data set, we will be needing the help of what? Pandas and stuff. So what I want you to understand is you might actually add some heading here. So you say, I'll just zoom this there out a little bit so that you will be able to see it. So you will say here, import, okay? Import. It doesn't really matter. Import all the what? All the necessary files or libraries for now, okay? Now, I'm going to add everything at once, and then I'll tell you what it means, okay? So from now, I will just Control-A, Control-C. I'll get back here. I'll just Control-V it. Now, please listen, guys. So for loading the data set, I'm going to break it up this way. For loading the data set, I will need what? Pandas, fine. And NumPy, fine. For visualization, I will need, that is to plot the graphs, right? I will need matplotlib. And I'm importing it, you know now, I'm importing it as alias, MP and PD, and as PLT. And I want to plot it inline. So I will use Seabond to give me that nice visualization. So for exploratory data analysis, right, I'm going to use what? Pandas profiling. Anyway, I will take this out because I'm running it offline, okay? So I will need a counter. And then for data pre-processing, right, so I will need, remember, what I want to do in data pre-processing is I want to standardize that. You remember, I just told you here that these numbers are actually not, they are not evenly represented. So for that, I will need standard scalar, okay, and which is present in sklearn pre-processing. Okay, I'll split this data if into training, so that the one I will use for training. So what happens in training is, okay, let's give an example of what is happening now. Here I can barely see two of my students. Diksha, are you still there? Okay. Amara, are you still there? Okay. I don't know, Jimen Suni, I don't know whether you're a student from MITM. And yeah, okay, Purushottam. So no worries, guys. Even if nobody is watching, I know that you are busy with your test, so I won't blame you. Okay. So now for that, what we are doing is, like, say I'm explaining now and some people are listening, others are not there. Now those that are listening, when I give tests tomorrow, they'll be able to perform, right? So that means during training, they understood, during testing, they were able to deliver. However, if I combine, I would just assume that everybody is trained now, right? So whereas there are only 2 of you here, okay, or 3 of you. Now when I administer test, what happens? So now if I give test, these people here will get almost a complete, they will get entire marks. Same thing when I give it to the entire population, then the accuracy, maybe only 2 of you again we get, but think of it, 2 versus 140 students. So it's around maybe like 0.8% or something like that. So you see, when the model performs better during training and performs worse during testing, we have a term for it, we call it overfitting. So to avoid that, we will split something, right? Reserve some for training so that it will not see the other side. Okay, it's not good you train everything, okay, and then during testing it doesn't perform well. Yeah, Fresh, nice to see you, welcome back. So that's why we do this. We have to reserve this side. So for me to say create, train, and test split, I better use this, which is present in scaling the model selection. Okay, now this is where we build the model, right? Data modeling. So for that, I need to use confusion matrix. All this we study in detail, okay, as the class proceeds. And I'm going to use what we call confusion matrix to understand how well my model performed, because we are going to have misclassified instances also. So confusion matrix is, in simple terms, I will explain that when we get there. We look at the truly predicted classes versus the ones that were predicted wrongly, because accuracy only looks at what was predicted correctly. Fine. And I'm going to look at the receiver operating characteristic curve, or what we call area under the receiver operating curve. And I'll use the classification report to plot some stuff, okay, which you'll be getting your F-score, your recall, your everything, and support and all whatnot, okay, not support and confidence now. So now the models I'm going to use, I'll be using linear regression, I'll be using naive-based classifier, I'll be using extreme gradient boot classifier, that is 3 already. I'll be using random forest classifier 4, decision tree classifier 5, k-nearest neighbor classifier 6, Gaussian naive-based 7, and support vector classifier, no problem. Now, finally, I'm going to combine all of them, right? Fine. So I will combine all. So that's why combine all, which is also known as what? Ensembling. So the question here is, must you import all these things before starting? The answer is no. Actually, I try to keep it here so that you remember, you know that one row refers to everything, right? Where you're importing everything, let it be in one row. Now, I will run this now, guys, and there won't be any error. However, when you run this yourself, you are bound to get an error. So it's executed, there is no error. So you get an error, and most of the errors would say like no Panda installed, no NumPy installed, no Seabon is not installed, or cannot find symbol blah blah blah, or something like this, okay? So when you get that, what you're supposed to do, say example, okay, NumPy is not installed, fine. What you're supposed to do, you just say, Google it. From there, okay, why don't I show you, let me show you from here. I'll open the other one, okay? I'm just going to type that, and then you see what happens. So in that case, let's say I want to use pandas profiling, okay? So for now, I don't want to talk about pandas profiling. That's why I removed it. I have not installed it. So let's say I just say import pandas profiling as pp. Now, when I run this now, I'm going to get an error. Look here, guys. So it says, go down. See, don't get confused. Just I ran one single line of code, and I'm getting hundreds of errors, right? So look at, it says here, cannot import ABC classes from pandas.com, blah, blah, blah. Just right click and search, okay? Google search for this. You are likely to learn that Stack Overflow, right? And then you see a couple of tutorials and things like that. So let's say you want to install this. First of all, it's not installed, okay? Somebody will say, go and they did this, set the path or something like that, but you know you have not actually installed it, right? So what I will do is, I will first of all go back here I will just change this. Instead of import, I would only type what? Pip install, right? So I'll change this. I'll say pip, okay, install install. So what I will do is pandas profiling, no longer as alias. I will just shift enter. Fine, it will install. All right, so let's proceed. Okay, now as that is happening, so it says requirement already satisfied. Okay, so let's leave this and then let's continue. Fine. So now this is done. What we're going to do is now we now need to load these data sets, right, guys? So for us to load the data sets, we have an already defined method. Fine. That method is called read underscore CSV. Fine. So this read underscore CSV, you're going to pass in the what do you call it? The file name. Now you can use single quote or you can use double quote also. For now, I'm going to use double quote. So what is the file name? Please remember the file is in the same location, right? See, the hard.csv, what I want to access, and it is present in this place. So you see this green one that shows that this notebook is what is running. This other one is like shut down, okay? So this notebook is running. So what I will do is I'm going to read this now. I will just say, what is the file name? Hearts. What is the extension name? .csv. Fine. So if you do this, okay, it's going to give you an error because it will say you cannot find this method read underscore CSV. Agreed? So this is present in what? Pandas package. So and we have imported panda as what? PD. Agreed? So since we imported pandas as PD, we now have to say, okay, PD dot, right? So PD dot read underscore CSV. But the question is, will this work? Yes. But it's going to display something. Just by typing this, it displays everything, showing me that I have 1,025 rows and 14 columns, right? But I want to refer to this. There is no variable now. I didn't store this. So that's why I will go back. I'll say, okay, fine. I want to store this in a variable called data. Fine. So when I run this now, I'm not going to get any output. So what I will do, I'll take this, Control C. I'll come down. I think I zoomed this out a little bit so that we'll be able to see. So I'll come down. I'll press this now. Now, when I run, I'm not going to get anything here. Why did this happen? This actually tried to display everything, right? So it displays everything, showing me the first 5 and the last 5, right? Fine. And that means it has shown the head and the tail. So how do I know it's the head or tail? There is also this method, right? Called what? Data. Called the head method, HEAD. Fine. That head, now remember now, though, whatever we've loaded, the data set is now presenting data what? Variable. So I will just say data.head. Now, head is going to show me the first 5. Now, as soon as I shift enter, now you see I have only the first 5 here. So if I want to get the last 5, what I will do, I will just say data.what? You got it, right? So I can actually do head of -5, okay? It will show the last one, or I'll just say .tail. Fine. So once I do this, I'm going to get the last 5. But this, we have not done anything, right? We just simply displayed the information, the data that is there. Another way to find out, like, instead of printing how many rows, because if you say head and tail, it did not give you this information, right? 1,025 rows versus 14 columns. Another way to get that is by calling this method called info. So, and that info now, we say data.info. So watch what will happen now, okay? Information about the data set. Now look here. It says I actually used what? Pandas library, find the data frame, and now I have the range 1025, right? Entries, that means 125 rows, starting from 0 to 124. And there are total number of what? 14 columns. Now, this information, extra information, you cannot infer it from here. You cannot get it from here, this one. Why? Because this we use an inbuilt method called info, all right? And it's going to show us, see, it is telling us that, see, I have gone through all this stuff. I found that apart from one, which was floating point, and we actually saw it. Look at the one which is floating points, right? What is the column name? Old peak. This is the only one that is floating point. The rest are integer variables, right? So apart from, let me see if there's any comments. So apart from, guys, and in another 30 minutes we are done. I won't keep you beyond 7:30, okay? So it says, apart from old peak, all other variables are of integer type, right? Cool. And if you keep scrolling, you might get tired, right? So there are about 1,000 and something of them, right? So why don't we do this in one line of code? So here you see in 1025 entries, there are no missing values at all. That's what this non-null means. And you can actually get the data type 1 only of floating points and 13 of integer type. And this is the memory space it has utilized, okay? And these are all the columns, and this is it. Fine? All right. So this is cool. So we have started a little bit of what? EDA. Fine? It's kind of. So now let's check, because we are not sure. So we want to ask, is there any null value here? Already we have answered it, right? But I want to now, let's say there are null values, I want to count them. So I will say it's null, fine, and I want to count them. So when I call the sum method, obviously from your normal Python stuff, it's going to say, see bro, I told you already from here, there are no null values, right? Just in case you didn't understand null value, remember null means empty. So none of them is empty. So even if you counted it, nothing is there. But I want to know, say example, if somebody asks you, what is the mean age? Please listen. What is the mean age of the patients here, right? Who suffered from disease or who did not suffer from disease? You know, okay, what is the mean age of the data set here? Please look here. So what you do, you come back here, you come back here, you can do age, mean age, mean age. Let's go back here, okay? So remember, this starts from beginning to the end, right? So you can take from here, take it, and then you go down, control down, right? So till there, you can actually select, right? That is 1026, and you just do what? You call what? Dot, what is it called? Sum upon what? 1020 something to get the mean, right? Or you just, can we get the mean score here? Let me say equal MEAN, yeah. A geometric mean. You can actually use the geometric mean of some number. So, okay. So instead of me to waste time doing all this, right? What I will do, I will just use what? Descriptive statistics in what? Pandas. So what I'm trying to tell you is you can actually do this analysis in Excel, but you might not be able to finish it up in a computational time, right? Or you might end up giving me things that I don't want to look at. Fine. So what I will do is I need this method, right? Describe. But when I call this describe, it's going to tell me, see, you are calling describe on which data set. So just let's do this. It says describe is not defined. Absolutely. That is because describe is not on its own, right? I have to call it on this data, right? So the data is where the variable where I have stored the data set, then I can actually do this. So as soon as I do this now, watch what happens here. So we can actually find the mean age, the mean sex. Okay, now please listen. He's taking all the zeros and one and adding it up. You remember, like human beings cannot be in between, right? Fine. Okay. So this is the mean. It has counted it. There are 1025 of them. All obviously this should be normal, right? It should be the same, right? I mean the first column, the first row actually. Now this is the mean age. This is the standard deviation. This is the minimum age. Okay. So the minimum age, that is the person who is, you know, you can actually find it here also. You know, by just taking entire thing here and just saying equal mean. Okay. So maybe one of these days we try to do the same analysis using Excel. Okay. So equal mean. Okay. You select the first number to the last to the end of it, and that's it. And then you're going to return 29. So maximum mean is 29, maximum is 77. Fine. 25th percentile and all whatnot. So we got this idea of how the data set is now. Now, what do we do now? Let's start now. Okay, since we have done exploratory data analysis, we know that there are no missing attributes, right? I mean, no null values also. All are numeric data sets. So what we do now is we now need to separate the heading. You remember, guys? So in case if you take a data set, you can actually take out this heading and save the rest. In that case, you're not going to do what I'm supposed to write next. Okay, so let me just not keep you for so long. I'm not going to type everything. Now, I will do something here. I'll just paste the code and then I will explain. So what we do is, remember this heading, age, sex, and stuff. I want to separate this guy into another variable, right? So I want to take it out and store it in Y. Fine. So I'm going to drop that column, that entire row, right? I'm going to drop the entire row. Now, the rest, I'm going to do analysis on, okay? So if I'm going to do analysis on the rest, that means I now need to break it up. That's why I imported trend test plates. Do you remember? Fine. That means the entire data set is, let's do the maths. Say the entire data set is 1,000. When we say test size of 1,000, okay, 20% of 1,000, we are going to get what? 200, right? So 200 will be used for test. So we don't say trend size. So we just tell test size because we are using a rule which we call 80-20 rule. Or you can call it 4-1 rule, 4:1, 80:20. That means 80% is reserved for training and 20% is reserved for testing. Now, random states, you can actually use 42, you can use a number, okay? Now, I'll come back to this. The reason why we are doing this is, now you might ask, how do I know 20% is the best? Please listen. I'll run this completely and then we go and change the test size, okay? That means fine-tune these hyperparameters to see which one is going to give us close to 100% accuracy. So for now, I'm going to leave it as 20%, fine. And remember here, some values are bigger than the other, right? So like these values I showed you initially, that's why we are doing what? Normalization, okay? Or you call this standardization for now, fine. And once I call this fit method, then I'll start training it, okay? And what? And then I'll leave this for test. So I'm going to run this now. And after here, you're not going to get anything because we have literally not printed anything after the what? After this method, right? So what we want to do now is, okay, let's now check if we have actually imbalance issue, because before I start burden the model individually, remember I have split this. What is now happened is in this X train, okay, I'm going to have what? 80% of the data. In X test, I'm going to have 20% of the data. But what if there are more ones than zeros? Please look here. What if there are more ones than zeros? Like if I ask you, how many zeros are here? Remember, this is the target variable. We have actually separated it, right? So this is based on this. We have based on all now. Oh, okay, that is also another thing. Independent and dependent variable. Okay, that means this target variable now is influenced by all these ones, right? So based on all these conditions, we are going to get what? This. So think of it as your y-axis, which is your dependent variable. So that means the target is dependent on all these attributes, right? Attributes here are columns. So based on all these attributes only, we will now say whether the person has this disease or not. Fine? All right. So because of that, I don't know whether there are more number of zeros than one. So let's investigate that. So I'm going to paste this now. So unique means like, without duplicates here. Okay. So on the training data set, let's see, guys. So you see, it's almost evenly distributed, 419 and 401, right? Remember, 80% of 1025 is around 820, okay? 80% of that, okay? Not 20%. 80% is for training. That's what I checked on the training. So now we use this counter. We imported it already as a header file. So I didn't write a method for it, okay? It's imported it as a library from collections. So I use that, and then there you go. So it is balanced. There is no imbalance problem. Now let me start building this model, right? So I'm going to build this and print the confusion matrix starting from any of them. So let me start with naive Bayes classifier, okay? So it doesn't really matter what name you give it. So I'll start with naive Bayes classifier. I'm going to paste this here. So I call this, maybe it is my first model, okay? I call this second model in this case, no problem. Now I'm going to use Gaussian naive Bayes. Now, please listen. I'm using most of the library files because no one will stay here for 10 hours just to do this project. Literally, this project will take, if you really want to do this and understand it from scratch, it will take you not less than maybe 8 or 9 hours. I mean, without inbuilt library functions, okay? So when I call this fit method, that means I'm training this on Gaussian naive Bayes. Finally, I want to print the confusion matrix, right? So in here, I'm going to print what? Please look here. The test, that is the y-test data and the predicted data. And then on the y-test, that is, please look here, the confusion matrix on the what? The training data, okay, and on the test data. So here I want to check how well this accuracy, this model did, okay? And the accuracy I will get, I'm going to multiply it by 100. Because, say example, if I'm going to get 0.92, I don't know what 0.92 is. So if I say 0.92 into 100, it's going to say it's 92. So you can actually concatenate what percent to that. So I will say shift enter. Now watch here, guys. So this will give you something which you might not understand for now. And I will explain this and then we run the rest. So what is the accuracy of this naive Bayes model? It is 80 something. So maybe if I take out this, look here, look at what I meant. Run this again. What did you get? Accuracy is 0.85. So this is what I want you to take care of, okay? So instead of you printing something like this, just multiply this by 100, okay? So that people will understand that this is actually the accuracy. Fine? All right. So now, you are going to get something which you may not understand. Look at this, guys. Fine? So what is this? What are these figures? Can somebody take your calculator and plug in these values? Just help me add 79 plus 96. Can somebody do that? So why don't we do it together, okay? So what I will do is, I'm going to keep this side by side. Can I actually write here? I don't really think so. So I just call up my calci, okay? Calculator, because we need to understand what this confusion matrix is all about actually. I don't know why it's called confusion matrix. The best name is actually classification matrix, okay? So let's add this up, 79 plus what? 96. Keep in mind what you're going to get. What did we get? 175, right? So this is 175. Now let's add up everything. So you just say plus 19 plus 11 plus 19 plus 11. What did you get? 205. So you're going to do 175 upon 205, right? So what did you get? 0.8 whatever, whatever. Did you see that? Multiply this by 100. So what, sorry, I did divided by 100. Sorry about that. But you got the idea. Can I actually do this? But you got the idea. So multiply by 100, you're going to get 85. That is this figure, okay? So what is this confusion matrix now? So in some literature, you might be seeing something like this. Let's take the same value and plug it in here. Do you remember the value, or you've forgotten like me? So do you remember the value? What was that value? Okay, they are not here. Okay, so the value, I think, let's just write this down. So this value is 79, okay, 79 plus 96 upon 11 plus 19, right? Sorry, plus 979 plus 96. No worries, plus 96. So what you see above is what we call, this is true positive. Okay, so let me write it in red now. So this is true positive, and this guy is true negative. All right. So let me just write this first. So I can say that accuracy of a model is defined mathematically as true positive plus true negative upon true positive plus, I'm going to write the other ones because you have not seen them, false positive plus, go back, true negative, you have seen it, plus false negative. Okay, so false negative. That means, you see, whatever we see here is all about correct prediction. Somebody has the disease and the model predicted they have the disease. That is the what? True positive. Somebody does not have the disease and the model predicted that they don't have the disease. That is true negative. I think this might not sync well. Let's just take another graphics. Okay, let's take some graph to understand this better. Fine. Now, look here, guys. So let's look at confusion matrix. Confusion. Remember, it's called classification matrix. Okay. So if you look at this guy now, what you're going to see is, please listen. I want you to say, maybe we go to images. I think that pregnancy testing, I want to use that. All right. So you'll be getting actual predicted, fine. Okay. Yeah, okay, I didn't want to use that for now, but yeah. So let's look at a binary classification. Yes, sir, is confusion matrix only plotted for two classes? No, you can use it for multi-class also classification, no problem. So look here, guys. So total number of instances are 165, right? Okay. Now, look at the diagonal. Look at the diagonal. The diagonal is 50 and 100. Did you agree? 50 plus 100 is 150, right? Then add this diagonal. 50 plus 100 is 150, then plus 5 plus 10, right? That is 165. So what is the true positive here? See, true negative, okay, because they kept it no here. Predicted no, actual no. So predicted no, actual no is Tn. Predicted yes, actual yes is Fn. Now, look at the only one that might be confusing you, right? False positive, right? Says predicted is yes, that is positive, but actually it's no, so it's false, right? Cool. So false negative says predicted is no, actually it's yes. So plug in the values here. Somebody does not have corona. The model predicted they didn't have corona, correct? Somebody has corona. The model predicted they has corona, correct? Somebody, please listen, does not have corona and they predicted that they have corona. That is false positive. Someone has corona and the model predicted they don't have. That is false negative. Now, let me ask you this question. between false positive and false negative, which one do you think is deadly? Please listen. Somebody does not have, the model predicted they have, versus someone actually has, and the model predicted they don't have. Which one? False negative, right? That's why in most medical research, we are interested in another thing called recall, F-score, or you might look into sensitivity and specificity, okay? Instead of you relying on accuracy. Because you think about this, 150 patients out of 160 were diagnosed wrongly. Correctly. 150 out of 165 were diagnosed correctly. How about the 15 that you diagnosed wrongly? Okay, you might say it is 165. Think of this on a larger scale, 1,65,000. 1,50,000, okay, 1,65,000, okay? So in 1,65,000, I don't know how to pronounce it, please. Let me use the Nigerian way. So you have 165,000 patients. In that, 150,000 patients were predicted correctly. So that means 15,000 patients were wrongly diagnosed. So if the person does not have disease and the model predicted that they have disease, actually they might die of hypertension, okay? They might die of, stress. I mean, thinking about it. And the worst case is when the person actually has the disease and the model said they don't have the disease. So that is what this confusion matrix is trying to help us do, okay? Now, another thing, I'm going to leave all these ones because I told you about precision. I just said about precision and recall. We leave it for now. And then the F1 score and support, okay? So listen, when you added all these things, what did we get? You're going to get it here, okay? So number of instances, so if you add these two up, it's going to sum up to do what? All the instances here, okay? So 205. So you add them, you get 205. So the accuracy of the model is 85%. The macro average, we look into this later, and then the weighted average. Fine? All right. So we have built with one model, and I'm almost done, guys. I'm almost done. Please hang in there. I'm almost done. So what we're going to do now is we're going to copy-paste quickly all the models, and then we now do an ensemble, okay? So Control-C, I'll come back here. I'll paste this. Now, I use logistic regression. What did I get? 86% accuracy. Wow. Okay, so 85, 86. Now, I'm going to build with what? Random forest. Okay, so now in our machine learning class, we will address how random forest and how all these things are able to make the prediction. Fine. In random forest, I'm getting 95% accuracy. Wow, that's brilliant. 95. Okay, because it is 94.6 something, that is 95. So I'm looking at this approximate value. All right, so let me use extreme gradient boosting. As I work on extreme gradient boost, let's see. Okay. Oh, wow. I'm getting again 95. That's brilliant. Now, let's look at k-nearest neighbor. All right. So I take for k-nearest neighbor, I'm going to see k-nearest neighbor is giving me 88. Oh, okay. So let's look at decision tree. Actually, I should have built it before the random forest. So anyway, so let's look at decision tree. In decision tree, I'm getting 95. Wow. These things are actually doing pretty well. So let's look at our support vector classifier now. So if I get back to SVC, I'm going to see this. Oh, wow. Look here. Wow, there is no false negative. Wow, wow, wow. Okay. Whoa. So this is 98%. Brilliant. Fine. If this is the case, guys, can we kind of visualize this to know the importance of each of these based on what? The feature which we are selecting. So I'm going to show you something here. I just called this important feature. And there is this acronym for color, which is called red, green, blue, cyan, whatever, magenta, and whatever cyan, okay? But this worked in earlier versions of Python. Now is what? Deprecated. Can you see that? So it's going to give you a kind of, what do you call it? Shouting error messages, right? And in most cases, you give up. So let's Google this, guys. Let's Google it. So what is this actually telling me? It says, please go down. Using a string of color character colors as a color sequence is no longer supported. The colors can be passed as an explicit list instead. So you see, this is why, I wanted us to spend some time, looking at list dictionaries and stuff. But no worries. Let's now right click and search for this. Okay. Now, if you right click and search, let's go back to Stack Overflow. And what is the error message here? Let's look for somebody who has, okay, this is not upvoted. I'll go back. I will just go back here. I'm quite new to Matplotlib. And then, yeah, so let's go by the year. So I'm going to look into the 2021 thing. Now, if you see here, yeah, okay, says no longer supported. And he did the same thing. And then this person says, follow the instruction. And just please look here. Look here now. It says, convert this to this. It will fix it, right? So, see, instead of you saying all together, convert it as a list. So that is it. That is what I'm looking for. But nobody upvoted this. So can we try it out? Age, you can actually say age color none. That's not what we are looking for. So I'm going to convert that to a list. Fine. And that is it. And actually, that was what this guy suggested you do. It says convert it as a list. So what I will do, I will come back here, okay, and I'm going to change this now from this. I don't want this. I want colors. And I just create some custom color, okay. Now, that means before I use this, I can create the color anywhere, right? So I just create the color. So I'm going to use red, green, blue, white, yellow, magenta, cyan, okay. Now, when I run this now, voila, there is no error again. So this represents my what? The important features. Now, if you watch here, what is the most important feature? CP. Can you see that? CP is the most important feature, followed by egrSZ, right? So I don't know what CP stands for. I think CP, we go back to that, hard disease stuff. Okay, you can go back there, and CP stands for chest pain, I think. Yes, chest pain is CP, okay. egrSZ is, I think that is, oh, sorry, they have now removed it. Yeah, CP is chest pain for sure, okay. All right, so that means chest pain is the most important feature here that always influences the possibility of somebody having a heart disease, followed by egrSZ, I think this, okay. But you got the idea, guys. Please go back and find the metadata and look at the description. I can't remember everything. And then the other one is CA. So what is the least factor that affects this person? I think, which color is this? I can't get this. I think the least factor is fasting blood sugar, FBS, okay. So this is what this affects this. So since we got this idea, where is my ensemble now? Where is my ensemble, right? So I need to do the ensemble, and then we are done finally, okay? So for that, I'm going to paste some codes, but please don't get worried, okay? So I want to know, remember here, there's another thing we want to use, right? Which is receiver operating characteristic curve. So let's understand this ROC. There's lots of tutorial on that, ROC curve, okay? So what does it mean? Simply put, if you look at this ROC curve, okay, so it is a graph showing the performance of classification model at classification threshold. The idea here is the closer it is to the top, the better the model. Okay, let's look at it. Look here. So let's look at it. So this is the worst classifier. Can you see that? Random classifier. Then which is the best? See, the blue, this one, all right? Closest to the point is the best classifier. The perfect classifier. Did you see that? So it has to get towards 100%. That is what we need, okay? So anything here below this threshold does not perform well. So let's look at many of them. Maybe we look at this guy. Let's look at this. So which one do you think is better ROC? This one. So this will actually tell us how the model improved over time. So for that, I'm going to plug in lots of annoying codes. Okay, don't get annoyed, okay? So I'm going to plug in lots of annoying codes here. Actually, what this annoying code is doing is trying to tell me, okay, looking at all these 7 models, right? So tell me which ROC curve is better. So look at it, logistic regression, naive based random forest extreme gradient, both this and that. Which one is better? Already you have seen it here, right? That it is what? Support vector classifier. So let's look for the legend. Support vector classifier is like, I don't know whether this is purple or something. So if you go back, it is like this color, right? Okay, so this is the one which is actually better, and it's almost near perfect. It's almost 100%. Okay, if that is the case, can you show me the accuracy of all these models in one go, right? Because see, we have used so many models, right? So if I ask you what is the accuracy of which one has the least accuracy, you have to scroll up, okay, and then find it. Which one has the most accuracy, you have to scroll up. So instead of that, why don't you summarize it here and print it in a tabular form? So now this is what this code is going to do. So if you zoom out now, you're going to see, yes, SVM has the best accuracy, followed by All these ones are same, I think. Yes, DT, random forest, and extreme gradient boost. Which one is the least? Naive Bayes. Fine. Okay. If this holds true, now I don't need to do anything, right? So what I need to do now is just to visualize this. Fine. So let me visualize all this and see, okay, based on the color codes. So remember, we already used colors before, right? So I'm going to compute now what accuracy against algorithm, or algorithm, accuracy against algorithm. That's accuracy on the y-axis, sorry, and then algorithm on the x-axis. Okay. So once I do this now, what I'm going to get is, see here, support vector classifier, you see, is tending towards 100%, right? Yeah, fine. So, and yes, followed by these guys, yeah, and then this is the least performing, naive Bayes. All right. So where is my ensembling now, right? So if you look at it, guys, so far, which one has the best? SVM. Now the next question is, will Ensemble give me better accuracy? So look here. So Ensemble, is it going to give me better accuracy? Let's find out. All right. So what I'm going to do is, I'm going to combine 3 best classifiers. Okay. So look at, what are my 3 best classifiers here? What are my 3 best? So I have support vector machine, I have DT, I have random forest. You can actually take the 4 because these 3, they are giving you the same thing. And you do this. So you do the maths. I think Yash will be able to answer this. Yash, do you think if I plot the aggregates, okay, of these 3, it's going to be better than SVC? Absolutely not, because it's going to give me the mean, right? So let's find out. So if I do this now, please watch now. What is the accuracy? 96%, right? 96% is the accuracy, whereas only SVM was 98%. So what conclusion do you draw here? What is the inference? And I wind up. So now I'm going to wind up now, okay? So I will just tell you the inference. Already you know. So first point, that this guy, what now? It says that is unmatched, no problem. So once you want to write, say you want to write something inside here and you get this error, what you do, you mark down this, okay? It's no longer code, just put it in markdown and shift enter. So SVM gives me the best accuracy, followed by DT, KNN, and what? DT, decision tree, KNN, DT, KNN, and random forest, right? And random forest, fine. Now, this accuracy was from naive Bayes, possibly because of the probability computation. Data analysis shows that exercise induced angina, that is chest pain, is the major symptom for heart attack disease. You can actually see it from here, right? So this is the major symptom, fine? And you can actually make again, see, if I ask you to draw 5 inferences, you can say that cholesterol and FBP and red type, whatever, has this does not literally have influence over this, the heart disease, fine? And finally, sadly, ensembling technique decreased the accuracy of this model, as the combination of SVM, KNN, and DT gave less accuracy. Now, in case if you are watching, okay, and I actually submitted this notebook before saying that Ensemble was better, that was because the data set we used was different from this data set, okay? Because here, initially here, the Ensemble was better. I think here, I actually reported here that Ensemble, the best was extreme gradient boosting, fine, and that ensembling technique increased the accuracy, okay? But the problem here was the data set was lesser, fine? I didn't use the entire data set, so that was the inference. So on this note, I want to thank you guys for listening, and yes, I'm really sorry I have overshot the time again, but yes, I believe I have done justice to this, and please feel free to just let me know how you find this tutorial. Or do you think, again, I should have you know, gone a little slower or something like that? But anyway, until next time, guys, happy studying. And in the next session, we are going to build something else together. Maybe we look into real-time tweet sentiment analysis. I'll tell you how to get the API key and everything. And maybe from September, I think end of September, we start deploying these machine learning models. We don't want it to be running from the notebook. We want to like take a data set, make prediction in real time. Thank you, guys. And until next time, take care. Bye for now.